Welcome. In this lesson, we're basically going to talk about graphs of angles in the XY coordinate system and what we mean by an angle in standard position. An angle in standard position always has one of its rays, one of the side of the angles, as the positive x-axis. So the vertex is right here at this origin of the coordinate system, and we have what's called our initial or our starting side of our angle. Then what we do is we rotate it to a final position, or what's called a terminal side. And so this one, and we always rotate in the positive direction. Well, we don't always rotate in the positive, but if we rotate in the positive direction, we go in a counterclockwise direction until we get to our final ray, our terminal ray, which is down here. And we ask ourselves, how much did we rotate? Well, that's a rotation of 270 degrees. So when it's asking which of the following shows a 180-degree angle, we need to make sure what we're starting here, and if we rotate 180 degrees, we should be coming out this way, which it doesn't have that ray there, but this one does. This one's a 90-degree rotation, 90 degree. This one apparently was all the way back around to its starting place, or a 360-degree rotation, or maybe a zero rotation, because they're both technically equivalent. But this one is a 180-degree rotation. So that is the one you would click. Now we're eventually going to get to radian measure, but let's do one more of these, 90 degree in standard position. So again, basically I want my starting ray to be here, and I want my ending ray to be here, which is not that one. It's not that one. It's not that one. It's this one right here. So it's the first one, is the 90 degree in standard rotation. A 0 degree, that's going to be the one that's like this one here, because this one's 180, this one's 270, this one's 90. Now we're starting to get into some partial angles. So again, a 45-degree angle in standard position. You always have to start here, and you're going to rotate in the positive or counterclockwise direction until you get to 45, which is this one. And now none of the others are even close, because that's well more than 90, that's well more than 180, this is well more than 270. So it's this one right here. I'm going to jump ahead because I'm pretty sure eventually they're going to get to, and again, it's just helping you see the quadrants, right? A 705-degree angle. I guess I should do this. So you're going to have to do a little math. You're going to have to go around once for 360, around twice for over, so I don't want to go that far. What I would recommend is taking the 705, minusing off 360. So 705 minus 360 is going to give us a total of 345. So what that tells us is we are going to start at the positive x-axis. We're going to rotate around 360, and then another 345 degrees, which puts us right here at this angle measure here. So when we talk angles as rotations, we can go a lot bigger than 360. Okay, I'm going to jump ahead because I know we get to radians, and I want to talk about radians. Oh, it better start giving me some radians, or I'm going to be, there we go, radians. Now, to make radians easier, I would highly recommend you take the time to realize that we still start at the positive x-axis. This here is still 0. Halfway around the circle, or pointing in the other direction, would be pi radians. So a 90-degree angle would be pi half radians. And if you were to go all the way down to here, it would be 3 pi halves radians, 3 pi halves. So when it asks for 3 pi halves, again, you're going to start at the positive x-axis. You're going to rotate to pi halves, pi, 3 pi halves. So you're going to end up there. And by the way, that was this graph down here, because that's where I started and that's where I ended up. The graph that I actually was just looking at, if you'll notice, and I erased that, that was a 90 degree or a pi halves angle. It wanted a 3 pi halves. So I'm going to choose this one here. Now we're going to do quarter angles. So again, take the time to think of this as 0, this as pi, around to there. So this would be pi halves. This would be 3 pi halves. And then you can start dividing them up. For instance, this is pi fourths. That was a horrible pi. Pi fourths. Over here would be 3 pi fourths. And think of it this way: 1/4, 2/4 is a half, 3/4, 4/4 is 1. Here would be 5 pi fourths. So in other words, I count by fourths: 1/4, 2/4, 3/4, 4/4, 5/4, and then I put a pi on the end because everything's in terms of pi when it comes to radians. So I wanted to actually start here and end there. Well, which one did that? That was this one. Starts here and ends there. So it's the first one that I wanted to choose. Again, 2 pi radians, that's completely around. Because remember, we start at 0, halfway around is pi, all the way around is 2 pi. So we started here, we rotate around till we get back to here, and that's where we see that other ray. There's only the one ray, so that's 2 pi. If you have questions on these, please bring them to class. But again, all you need to do is I'm going to start going by pi sixths. So I got 19 pi sixths, which, yeah, I'm just going to start. I believe it's this one here, but I'm going to show you why it's this one. I'm going to start with 0. I'm going to go to pi. And how many 6 is that? That's 6 sixths pi. That's 1 pi. Over here would be 12 sixths pi. In other words, I'm going 1 6, 2 6, 3 6, 4 6, 5 6, 6 6. And then I get to 12 6. So again, all the way over here, so I went around here. I'm going to go all the way back to here. So that to that point, we're at 18 sixths pi, because that's 3 pi. And then I need to go 1 more pi, 1/6 more. So right here, if I go this 1 more, that's going to be 19 pi 6. It will take some practice. Try not to get frustrated. Bring your questions to class. Whoops, I didn't click on it apparently. And I will help you get this process of walking around, going by 1 6, 2 6, 3 6, 4 6, 5 6, 1 or 6 6 pi, 1 pi, 7 6. So I should be right here. That's this one. Have a good day.